Yeah, there is.
All right, any questions?
Are we doing the same thing as yesterday, but like in the same direction? Like those are both facing right, and I'm assuming one is gonna slam into the other, and then we're gonna calculate something.
They're not gonna stick together.
Slam, I said.
Yeah, well,
Okay.
it is different from yesterday in the fact that they won't stick together.
Okay.
Other questions? All right, this is a perfectly elastic collision.
Oh, okay.
Let's talk about collision.
And based upon your notes from yesterday, what does that mean?
Perfectly elastic collision.
Yes.
Kinetic, change in kinetic energy equals 0.
Yes. It's collision, so momentum's gonna be conserved. I haven't added any additional external influence, so we can assume it's a closed system.
What's
Momentum is
the-
conserved, and so we have, that gives us one equation. It's perfectly elastic, so kinetic energy is conserved, so we have a second equation. The question is, what are the velocities after the collision? Now I'm gonna go through three methods of solving, we throw in one other bit. It's a one-dimensional, perfectly elastic collision. One hint on solving the perfectly inelastic versus the perfectly elastic. For the perfectly inelastic collision, the question usually is, what's the final velocity? Singular, because there's one. In ones where they don't stick together, it's what are the final velocities, plural. So I want to know what V4 final is and V8 final. Because, oh, yes, Abby.
Did you change the homework quiz to the 6th?
I did, because the 7th is a lab.
Okay.
Thank you for bringing that up. I meant to say something. I was so used to every other, I was used to a Tuesday, Thursday class. Is that gonna mess you up?
No.
Okay. Yes, please note that the homework quiz for chapter 7 is on a week from today, not a week from tomorrow. All right. Now, the more subscripts and the more stuff I write, the more apt I am to make a mistake. So what I'm gonna do is I'm just going to set that equal to P and set that equal to Q, just so I don't have to write as much.
Does that have any significance?
No, I'm just picking two letters that we're not using for anything else really. Oh, we're using P though, for momentum.
Z? Z?
L.
We're not using L yet?
No.
We're not using L. And,
Q.
what'd you say?
Q.
Why can't we keep Q? Was that also
Said Q?
used?
Yeah, we need, okay, L and Q. So conservation momentum, momentum before equals momentum afterwards. What is the momentum of this?
10 meters. I lied.
Momentum? That's 40 meters before kg over us.
Newton's times seconds.
Yeah, Newton times second. There are a couple different variations of the units. But all right, so we have 40. Plus, this is our conservation, the change in momentum, 0. What's the momentum of this? I think I heard somebody say it.
8
All right.
times seconds.
And that's going to be equal to the momentum afterwards. So it is 4L plus 8Q. What equation? Two unknowns. Any questions on the first equation? Because it's perfectly elastic, I know the kinetic energy will not change. So, you should all know the formula. What's the formula for kinetic energy?
1/2 mv squared.
It's not a race. All
I'm
right,
not being erased.
so I have 1/2 times 4 times 10 squared plus 1/2 times 8 times 1 squared is equal to 1/2 times 4 times L squared plus 1/2 times 8 times Q squared. I have two equations, two unknowns. If they are independent of each other, which they are, then we can solve it. It is now a math problem. And then we'll come back at the end and use physics to interpret our answers. Just simplifying this a little bit. So for that first equation, we have 48 is equal to 4L plus 8Q. And then down here, I've got, that is 200. That is 4. 204 is equal to 2L squared plus 4Q squared. All right, now what?
Now we can make L equal to 48 minus 8Q over 4, and then substitute that.
So from this one right here, we have 4L is equal to 48 minus 8Q, or L is equal to 12 minus 2Q. Now what?
Now we substitute that in the second equation where it says 204 equals 2L squared plus 4Q.
So I have 204 is equal to 2 times 12 minus 2Q squared plus 4Q squared.
Oh, the squared applies to the whole term?
L square is, L is squared, and L is 12 minus 2Q, so 12 minus 2Q must be squared.
How did we get 12 minus 2Q again?
From this equation right here, subtract 8Q from both sides. So we have 4L is 48 minus 8Q. And then divide by 4. 48 divided by 4 is 12. 8 divided by 4 is 2.
Oh, okay, let me write that down then.
Okay, now what?
Now we just solve the problem. Like,
Well, that could have been said at the very beginning, so let's be more specific.
we multiply, well, we figure out the exponent, so 12 minus 2Q squared, is 4Q squared, minus 48Q,
What was the first thing you said? I missed it.
4Q squared, right?
Oh, okay.
And then minus 48Q plus 144. And then plus 4Q squared. And then we multiply what's in the parentheses by 2, and then combine like terms, and then move 204 to the other side and solve it as a quadratic.
variance there.
I got the same thing.
We could simplify it in this particular case, can't always, but we can here.
They're all like terms of. Yeah, by 12.
Yeah, if we divide everything by 12, we get 0 is equal to q squared minus 18 q,
No, 8Q.
8q, thank you.
You're good.
18 seems a bit high there. Minus 8q plus
7.
7. Now what?
We use the quadratic formula.
Sure, if you want. So q is equal to 8 plus or minus the square root of 64 minus 4 times 7 times 1 divided by 2 times 1. So 8 plus or minus the square root of 64 minus 28 over 2, which is plus or minus the square root of 36 over 2, which is 8 plus or minus 6 over 2. We get 2 answers. We got 7
And 1.
and 1.
What are the units? Meters per second?
Yeah, remember ultimately q is the speed, is the velocity.
Yeah.
If we plug into our equation over here, we can find L, or the final velocity of 4. So from this one right here, so if q is 7 meters per second, then we get 12 minus 14, or negative 2 meters per second. And if q is equal to 1 meter per second, we get 12 minus 2, or 10 meters per second. All right. One of these answers is correct, the other answer is not. Which is the correct answer and why? Pardon?
10 meters per second.
Is the correct answer?
Yeah.
Why?
Because the positive direction is this way.
Yeah. So after the collision, it's still going to be going in the positive direction?
No.
Okay.
Yeah. We'll go back. To the negative side.
Why?
Because after the collision, it'll be pushed back.
Is it?
Or not?
My comment before was that was not a valid reason for why 10 should be correct.
But wouldn't it?
Just as the other one's negative is not a valid reason why
Yeah, but wouldn't
that's correct.
the 8 kg thing stop it and it'll push it the other way?
Yeah, but that means it's going to slow down from. So take that argument then.
Okay. And put it to the 10?
So if it collides, 4 will be pushed in that direction. Which means what's gonna happen to its velocity?
It's going to be
You have to talk louder.
Oh, I'm not talking to Ansel. I'm just talking to myself.
Okay.
Yeah.
And talk as quietly as you wish.
If it was 10, would the velocity not be like?
Sorry,
Would the velocity not be the same as when it started? If it,
it will not.
so then,
You were almost there, Abby. And I don't know if you actually said it and I just didn't hear it. So if 4 hits 8, 8 is gonna push that direction on 4. Acceleration is opposite direction of movement. Sorry, force is opposite direction of movement, therefore acceleration is opposite direction of movement. Therefore, it has to change. It has to slow down.
But, so if it was, so 10 would suggest that it stayed the same, which is not true?
Correct.
Okay.
All we did mathematically is we want another situation where the momentum is the same and the kinetic energy is the same. One of those solutions is that they haven't hit yet. The momentum of each object doesn't change until they collide. So the advantage of this method is the fact that one of the solutions should be the original problem. But because they collide, it is not the final answer. It is just, this tells us, hey, we did something right. So we have an immediate check in this method. The disadvantage of it is you do have to use the quadratic formula.
No, you,
Well,
only
you're
if
correct.
it can't be factored.
This can be factored just because I picked numbers that could be factored. If I'm just putting numbers down, odds are you're going to be using quadratic formula, which would be easier than factoring. All right, so the final answer is 7 meters per second. So this is before, and then after, that is going to be going at, not 10, that'll be going at 7 meters per second. And this one will be going backwards, or opposite direction it originally went, at 2 meters per second. Now, some people don't really care for the quadratic formula, for whatever reason. Questions before I show you a different way of solving the same problem? Yes?
You said that, how we got 10 meters per second, that was basically showing us that we did something right. Would that always be the case?
If you use this method, you will always get the original non-collision case.
Oh, okay, so then basically you can just say, since I got that answer, and that's the same thing as the initial velocity, is the other answer would be correct.
Yes. All right. Let's look at it differently. Let's just put in generic letters. So what I want to do is I have two objects that are going to collide. I've got some mass m sub a traveling to the right at some initial velocity of a. I have m sub b traveling to the right at some initial velocity, or traveling in some direction. I guess if we establish A is traveling to the right, B can travel in either direction, just so long as they collide. If they're in the same direction, A has to be bigger than B. If they're opposite directions, it doesn't really matter. If it's a perfectly one-dimensional, perfectly elastic collision, I know that m sub a times a plus m sub b times b is going to be equal, and I'll use the same letters over there, m sub a times l plus m sub b times q. That's just conservation of momentum, which is true in a closed system. Again, in a perfectly elastic collision, the kinetic energy is conserved, so I know that 1/2 mass times velocity squared, or speed squared, of the first one plus the same for the second one is equal to the sum afterwards. So a l squared plus 1/2 m sub b q squared. So I have two equations. In a typical problem, you know big A and big B and the masses, and you're solving for L and Q. So the first thing, I'm gonna simplify that second equation. I'm just gonna multiply everything by 2. So I'm left with m sub a squared, plus m sub b squared is equal to m sub a L squared plus m sub b Q squared. The next step is I want to get all the similar masses on the same side. So I'm going to get all the MAs on the left-hand side and all the MBs on the right-hand side for both equations. So for this equation here, I have m sub a big A squared minus m sub a big L squared is equal to m sub b Q squared minus m sub b big B squared.
Why did we multiply it by 2? To make sure that everything's just not 1/2?
Yeah, to get rid of the halves.
Okay.
So that's this equation here. This equation here, I'm gonna do something similar. So I have m sub a big A minus m sub a L equals m sub b Q minus m sub b big B. I'm now gonna factor. I factored the first one, I can factor MA out, and I'm left with A squared minus L squared is equal to MB times the quantity Q squared minus big B squared. We can factor this again. What is A squared minus L squared factored?
This is the same perfectly elastic collision.